Matt Richardson is here. He is a maker, a Raspberry Pi expert. In fact, he's the first U.S. employee of Raspberry Pi. Congratulations, Matt. That's great. Your new book just came out, actually version 2 of the book, Getting Started with Raspberry Pi.
That's right.
Make Magazine's publishing that.
Yep, they're great.
So, first of all, fill us in. What is the Raspberry Pi?
So, Raspberry Pi is a full-on computer, and I mean that earnestly. So you can connect a keyboard and mouse to it. You can connect a monitor as well, and I'll do that live.
You're setting up the USB, the HDMI.
Yep.
It's got memory, it's got a processor, it's got storage.
That's right, and I'm using just a regular cell phone charger here to plug in.
That's great. So that's micro USB.
Yes, instead of a hard drive, we have a micro USB cable.
Oh, and look, it's booting up.
Booting up here.
I love that. So this is booting up, it looks like Linux.
Yes, this is Linux. Our engineers work on a version of Debian called Raspbian, which is really suited to our mission and our hardware.
Well, it also has to fit the processor. It's an ARM processor you're using in there?
ARM v7. Okay. The brand new one, Raspberry Pi 2, has got a quad-core 900 megahertz processor, 1 gig of RAM, still just $35.
That's kind of mind-boggling that I can buy a quad-core computer for $35.
Yeah, and that's our whole mission, is if we can make computers affordable, it means that more kids can play with them, try them out, they can experiment with them. If they mess something up, not a big deal. Just get a new one, or in fact, you probably don't even need to. You just swap out the micro SD card and you can get going again pretty easily.
Well, I know this was created for education. So we talked to the Raspberry Pi founder. He was inspired by the BBC Micro, which taught a lot of kids it was their first introduction to microcomputing. This is, how many units have they sold now, Raspberry Pi?
We're right about at 6 million now.
6 million?
Yeah.
Now, I have to say, a lot of parents get it for their kids and projects. And soon, I think, because of the Internet of Things, people are going to be, I know people using this for home theater PC systems. There's a lot of usage. It isn't educational. It's just a very inexpensive, very powerful computer.
There's a wide breadth of uses. We see a lot of use in education, of course. We see the hobbyists using, doing all kinds of crazy projects, and then also just the basic home theater PC stuff, as you mentioned. There's also the industrial use as well. Companies are using Raspberry Pis in their labs to prototype things, also create sensor networks in their warehouses. Tons of use in industrial. We don't always hear about it, though. It's usually when I'm visiting a company and they say, hey, take a look at this. You can't show it to anybody, but hey, here's a way we're using Raspberry Pi.
So there's no restriction in the license that prevents you from using this for commercial purposes?
You can use it for whatever you want.
Whatever you want. You bought a computer. Now, the $35 doesn't come with storage, right? So
That's
you have to buy a memory card.
Regular micro SD card, so the same kind you put in a digital camera. You get them at a drugstore, pop it in. They're really cheap these days. 8 gig card will do just fine.
8 gig's enough?
Yeah.
4 gig for Linux, and then 4 gig for your project?
Yeah, a little extra, and then any additional is helpful if you want to do extra stuff. Just download the software onto the micro SD card, pop it in, and you're booted up a full computer.
That's really amazing. The software is available online, doesn't come with it, so I have to download it. I could download another computer, put it on the SD card, and that's it.
That's right. And there are people out there who sell micro SD cards that are preloaded with the software. And then also there are tons of other operating systems made by our community.
Yeah, there's an XBMC for Raspberry Pi. There's a lot of stuff like that.
We're seeing a lot of people using Ubuntu now with Raspberry Pi. It's fantastic. So I launched into our desktop environment here.
Oh, you even have a graphical user interface?
Yes, a full-on desktop environment. And to show you a little bit about our mission here, we have a whole section for programming Python 2.
Mathematica? This comes with it?
Yeah.
This is free?
You can use it for free. Yep.
Isn't Mathematica like thousands of dollars?
It's pretty expensive. You get it for free on Raspberry Pi. It's our partnership with Wolfram.
Thank you, Stephen.
Yep.
You also get Wolfram itself, the Wolfram language, their new language.
Right. Yep.
You get Python 2 and 3. Scratch is a great teaching language for kids.
Absolutely. Our resources use Scratch for the younger kids and Python for the older kids.
Makes a lot of sense.
Yep, they're great programming languages.
And what is that Sonic Pi? What is that?
Sonic Pi is a programming language for making music. Use procedural code. It's a great way to learn loops. When I see kids using Sonic Pi, they really take off because you type in 2 lines of code, you got music playing, and then before you know it, they're iterating on that. It's a fantastic tool.
Wow. So if you've got a monitor lying around, an old keyboard, an old mouse, it's just kind of USB standard stuff, right?
Yeah, absolutely.
HDMI supported monitor.
It's all a la carte. So usually you have stuff laying around so that with just $35 you can get going. All these components, you can get a keyboard, mouse, $10, maybe even they find them in a junk pile in a company or something.
Most people watching this show probably have a few mice in the closet. So in programming, when you first use a new programming language, you write something called Hello World, the simplest possible program. And it teaches you, how to create a program, how to compile it, how to run it, where the output goes. You've got a hardware hello world for Raspberry Pi.
Yeah, absolutely. So a lot of people use these pins on the Raspberry Pi. These are the GPIO pins.
This is so funny. This term has come up on every single Screensavers show for the last 4 episodes. General purpose input output.
Right. So you can program, you can read and write these pins to do whatever you need them to do.
And there's a lot of them.
Yeah, we've got 40 of them on there. They have different functions. They can change their function as well. So the very, very basic way that you can program these pins is just by turning an LED on and turning it off again.
And there's like a command that says turn pin 30 on.
That's right. I'll load up here our file manager. I wrote a little bit of code in Python to, let's see, blink.py. It's a regular Python script here, and I'm going to move
so
the
you
terminal.
Import a few libraries so you can talk to the GPIO.
Right. That's right.
And you need a couple of little routines from the time routine, mostly just the sleep. So you set the mode, you set warnings to false because we don't want to see any errors.
Right.
You set up the GPIO, and now we got a loop. While true means keep doing this.
Keep going on and on. Turn the LED on, turn it off. And so now we just have to wire up the LED here.
And you did pin 21.
Yes.
So you know where to plug that in.
There's a guide for our pinouts there.
Okay. You're putting the
two,
green lead on one and
just missed it. There we go.
Yeah.
So we got the LED connected.
So now if you run this program, if all goes well,
yeah,
the LED should go on and off.
And we have to do it as super user. So then Python.
And 21 is what? Milliseconds? Seconds?
21 is the pin number that we're using.
Oh, that's the pin number. Well, how do we know how long it's going to go on?
1 second. The sleep command there shows 1 second. So
I
it'll be
see.
1 second on.
Sleep 1, sleep 1. Okay.
So then I'm going to execute this, blink.py. And we got a blinking LED. That's
here's
the
the test.
World.
Is it? Yes, every second it goes on and then it goes off. But you know what? That is really gratifying to be able to write something on the screen.
Well, you've got to start somewhere. And this, if you can make an LED blink, you can make a motor run, you can turn lighting systems on and off. This is where you start.
Tell me about this breadboard you're using.
So this is a basic prototyping breadboard. When you're just experimenting with electronics and you need to move things around, you'll plug your components in there, and then you've got some power rails if you need them.
And it's kind of a, it's a grid. It's an XY axis.
Right.
A through I or J there, and 1 through 30 there. And so you know where every pin is by its designation.
It's just to help you make connections between components.
Right.
Later on down the line, when your project becomes a little bit more real and it becomes more of a product-looking thing, you'll probably solder something together. But this is where you're just going to try things out, so you don't have to solder something down and desolder it, which is a difficult thing to do.
You just plug it in.
Right.
And you've got a light-emitting diode. That's the thing going on and off.
Yep.
And that looks like a resistor in
That's
there.
right.
Why is there a resistor?
You have to limit the current to the LED. You'll blow it out if you let all that current
That's
through.
part of the fun, kids, is forgetting the resistor, and then you go, oh, I think I need a resistor next time.
Right.
That's great.
Right.
Where do you get all these parts, though? I mean, we used to be able to go to Radio Shack and get resistors. I haven't been able to do that in a while.
You can get them all over. Any place you get a Raspberry Pi, like MCM Electronics, you can get these accessories as well. Adafruit, they've got a ton of great stuff that include the breadboard, components. They've got kits.
I would love to just have 100 resistors of different ohms, just a variety of things.
You can buy like a shelving unit that has bins in it. The resistors are preloaded. It makes your workshop look really hardcore.
What should we build today, kids? How neat is that? So that's Hello World for hardware.
Right, that's right.
We got it blinking.
Yep.
Very simple, and you're running software to do that. And you can do it in Scratch too, right?
Yeah, absolutely. There's a library that you can add onto Scratch to do GPIO stuff, and you can build robots with Scratch if you wanted.
What fun.
Yep.
What else should we know as we get started? You've got other stuff.
Yeah, I got something else I wanted to show. So in November, astronaut Tim Peake, he's a UK astronaut. He's going up to the International Space Station for a 6-month mission. He's taking 2 Raspberry Pis with him.
Wow, that's cool.
Yeah, it's great. And the kid, there is a competition going on in the UK right now where kids are writing the code that will run on the Raspberry Pi. So you've got
Astro Pi, your code in
Yep.
space.
Yep, so kids can write the code that'll run in this sandbox in space because you've got all these critical life-supporting systems on the International Space Station. You just can't run any code you want.
No, of course not.
So you can run it on the Raspberry Pi. This Raspberry Pi will be sandboxed. The students are writing experiments. And
how do they communicate with it?
So what they'll do is they'll have the data right off to the card, and then when Tim Peake comes back to Earth after his mission, he'll bring the data back down.
And there's an actual experiment, or is it just lighting something up for fun?
Well, there's a bunch of different sensors on this Astro Pi hat. And a hat, by the way, is a hardware attached on top. It's an extra module that you can add onto the Raspberry Pi.
Oddly enough, it's just like a hat.
Right, exactly. It sits right on top. And there's a bunch of sensors on there. Humidity, temperature.
Cool. That's what these are?
Yep, well, these are a bunch of LEDs. Now, I can light up those LEDs. I wrote a little bit of code, and hopefully
Oh, look, it's saying something. New screensavers in space. That's awesome.
So yeah, that's how the thank you. So that's how the astronauts will be able to interact with Raspberry Pi, because they're not going to be able to get it onto the network because there's a lot of certifications you have to do in order to do that. So
that's
put a little mini screen on there and a bunch of components.
But this hat has sensors built in for a variety
absolutely.
of things.
And right now it's going through flight certification. You just can't send something to the International Space Station.
You should be able to send anything. They send hamsters. You should be able to send a Raspberry Pi. Come on.
So we've partnered with
What
UK.
could possibly go wrong?
Right. So UK Space Agency and the European Space Agency, they're helping us to certify this hardware to go up onto the International Space Station.
Kids are lucky today.
Absolutely.
They got 3D stuff. They can send a computer into space. I bet you that Raspberry Pi has far more computing power than the Apollo 11 landing module. I mean,
I'm sure, yeah.
Easily. That is so amazing. And it all starts with a $35 Raspberry Pi. You can even get the older Pi, right?
Yeah, the older Pi is available now for $25. Wow. We even have a version now for $20 as well. It uses less power, has fewer USB ports. So there's really no excuse now.
It's a good idea, though, to go to a site like Lady Ada's Adafruit.com or MCM.com.
Yeah.
Because, is it MCM.com?
MCMelectronics.com.
Because those people, you know, they're official, and they have all the pieces you need, and they have a lot of explanatory stuff.
Yeah, they do a really great job with their kits and their tutorials. And there's also kits. There's so many different places to get kits. If you don't have anything, you can always buy a kit that's got a bunch of these electronic components built in already. Or, yeah, Adafruit, I love them. I love MCM Electronics as well.
And you probably want to get the book from Make Magazine. It's Matt Richardson's Getting Started with Raspberry Pi. The second edition just came out. You could get an ebook or you can get a physical. I like having a physical book when I'm working with hardware. I can crack the spine, lay it out flat. I can look back and forth. So get a copy. Matt Richardson, nice to meet you.
Nice to meet you.
Thank you for doing this. Congratulations on being the first U.S. employee for Raspberry Pi.
You.
We kind of have a soft spot for Raspberry Pi, so I'm really glad
to hear it.
You're here and doing this. Thank you for being here. I appreciate it.